Hello, everyone, and welcome to this monthly webinar on the Southwest drought conditions and resources. This monthly webinar series is produced in collaboration with the USDA Southwest Climate Hub. Emily Elias is on the line from the Hub. We'll be hearing a little bit from her later. This is intended to provide a quick update on drought conditions across the Southwest. These 30-minute briefings began during the 2020 Southwest drought from the Drought Monitoring and Reporting Team of the Southwest Drought Learning Network. I feel like I'm saying the word Southwest a lot, but I'll roll with that anyway. And we'll continue doing these monthly half-hour drought briefings for as long as the area is in extreme and exceptional drought conditions across the southwestern US. I mentioned the Drought Learning Network a second ago. The Drought Learning Network links climate service providers with resource managers, and we bring people together to share, to do peer-to-peer learning, increase landscape and community resilience in the current and future droughts, and really try to build that network that we all have of the people who have drought information with the people that need it. My name is Joel Lisenby. I am the Regional Drought Information Coordinator for the Intermountain West and Southern Plains Regions Drought Early Warning Systems at NOAA's National Integrated Drought Information System, or NIDIS. For those of you that may be unfamiliar with NIDIS, you can learn more about us at drought.gov. To begin, I would like to acknowledge that the land that each of us is on today is the ancestral land of tribal and indigenous cultures, and pay my respect to their elders and chiefs both past and present. And I welcome all tribal and indigenous people who are joining the webinar today. The format of today's webinar will be a presentation by our two invited experts, followed by a time for question and discussion. If you would like to ask a question, please type it into the question box, which is a little different from the chat box in GoToWebinar. It's the one that says questions on it. Feel free to enter questions as we go along, anytime you have something that pops into your mind, and we will have the panel address them at the end. And the questions will be moderated by Emily Elias, the director of the USDA Southwest Climate Hub, who I mentioned just a minute ago. And before I forget, I really want to extend a great big thanks to Emily for helping put all of these webinars together. I think she and I make a great team, and we are planning these, as I said, it doesn't look like the drought's going away anytime soon, so we'll be doing these monthly for the foreseeable future at this time. So in GoToWebinar, everyone is muted, and just so you all know, this webinar is being recorded, and the recording will be available on the NIDIS YouTube channel, and you can find it at drought.gov/webinars. So with that, I would like to introduce our two speakers for today. Our first speaker will be Dr. Steph McAfee. Steph is the Nevada State climatologist and an assistant professor at the University of Nevada in Reno. She is an applied climatologist with experience in analyzing both historical climate and projections of future climate, and in applying that information to resource management and conservation questions. And Steph will be talking about current drought conditions. Immediately following Steph's presentation, we will hear from John Gottschalk. And John, I don't know if I'm saying your last name right, so you might correct me later. John is the chief of the operational prediction branch at the Climate Prediction Center within NOAA's National Weather Service, where he is responsible for a suite of subseasonal to seasonal climate outlook and monitoring products. Prior to his current role, he served as the Climate Prediction Center's head of forecast operations, and John will be talking specifically about the seasonal outlooks and other outlook products. So with that, I will pass over to Steph for our first presentation.
Hi there, just one second. I am gonna show main screen. All right, good morning, everyone. I hope that you are able to see my main screen.
Looks good.
With everything on there, great. Okay, it's nice to talk to you all this morning, and I'm just gonna give you a quick briefing of drought conditions. So, you know, as Joel mentioned, It seems likely we're going to be in drought for a while, but I did want to acknowledge that this summer we had a pretty wet monsoon. There was very heavy precipitation across many parts of the Southwest, including Arizona, New Mexico, Southern Nevada, and Utah. But despite that monsoon, drought is still widespread across the West. I apologize, this is last week's Drought Monitor. I was going to update to this morning's freshly released map, but for much of the Southwest, it looks quite a bit like this one. So you can see drought across large portions of the West in varying severity, from just abnormally dry and moderate drought conditions in parts of Arizona to exceptional drought across the Sierra Nevada and parts of Nevada and Utah. So how did we get here? We can see that in the Southwest, we actually ramped very quickly, or relatively quickly, into quite extreme drought. You can see here the percent area of the Southwest. It's the little snapshot in the upper right in different kinds of drought. And this is the most expansive D4 drought in the Southwest that the Drought Monitor has recorded. And we also got there very quickly. Well, it depends a lot, but it appears that in this particular drought, temperature has played a big role. If we go back to sort of the start of this water year, we were already in tough shape. There was a lot of D3 extreme drought across parts of the Southwest, notably Utah and Arizona. And then we had a dry winter. Decent parts of the Southwest saw far less than half of their normal precipitation between October and December. And January to March was a little bit better, but in parts of Arizona and Southern Nevada in particular, it was really quite dry. And this summer was actually pretty wet, at least in some parts of the West. If you were in parts of Arizona, New Mexico, Utah, a couple little areas of Southern and Eastern Nevada, you got 2 or 3 times the precipitation you would normally expect to see in July and August. And in many cases, that came within the space of a few weeks. So we had this drought and then there was flooding on top of it. If you look at that little map up in the top left corner, you can see it was an interesting summer. There were places where it was the wettest summer, wetter than any other summer between 1895 and 2010. But if you go to California, there were, of course, the Central Valley, it was drier than any summer between 1895 and 2010. So how really is this impacting us? Well, stream flow is reflecting the combination of that dry winter that we had, the existing drought conditions, summer rains, and then management decisions as well. So on the left, you can see over August, the percent of median stream flow at the Huck 2 level, so at that big watershed level. And what you can kind of see is, right, in the sort of lower Colorado, 110% of normal flow. I have no idea why California looks normal. But everywhere else, right, the Great Basin streams were averaging at about 66% of normal flow, and 72 to 73% elsewhere in parts of the Southwest. If you zoom into a finer scale, you can see that things are actually much more variable. There are some basins in Arizona where stream flow was 200, 300, 400, even 1,000% of what we would normally expect, but other basins where you're looking at maybe a third of the expected August stream flow. And this is really focusing on this is really reflecting whether or not you were in a place that got some heavy summer rains and how those flows are being managed. Reservoir levels are pretty low, in some cases pretty dire across the Southwest. What you can see here is those colored bars are the percent of usable contents, and that black bar is where you would expect it to be at this time of year. You can see in most of the Southwestern states, there is less water in the reservoirs than we would expect for this time of year. It's particularly dire in places like Arizona and Nevada. Just if you're curious, we now have 2 reservoirs in Nevada that are at 2 and 4% of their capacity, which is, yeah, it's dry, but that's odd even for us. Lake Mead levels, of course, have fallen to shortage levels. They've dropped below that 1075 tier 1 shortage level, and we're looking at reductions in water to Nevada and Arizona in the coming year. In many places, the drought has also led to pretty significant wildfires. It's not a record summer nationwide. Much of the east has been pretty wet, but in many of the mountainous areas, we've seen really significant fires. Here in Nevada, we've actually, and parts of Arizona and New Mexico, we've seen fewer fires, probably partly because of the wet monsoon. And in Nevada, it's actually partly because it's been so dry, we didn't get very much grass growing this year. So if you get out in those low elevation areas, there's just not that much to burn. But this fire season started early. A lot of the fires have been pretty large. And so we hit preparedness level 5 on July 14th of this year. If you go back to 1990, that's the 3rd earliest it's ever happened. Being at this really high resource utilization level is pretty unusual in July. You know, at this point, any federal employee who is certified to fight wildland fire could get asked to go do it. And at last check, I think there were over 20,000 people working on fire suppression in the US. Now, soil moisture is starting to recover, especially where we got a lot of those summer rains. You can see on the left, the late August, early September, soil moisture is above normal where it's blue, below normal where it's brown. So Arizona, New Mexico, Utah, really soggy in the topsoil, at least according to remotely sensed data. And the subsoils are reflecting that as well, although of course they're responding a little more slowly. It just takes time for the water to get down there. And the drought means that we're also seeing some fairly significant agricultural impacts. I'm just going to show a couple examples here that are pertinent to the Southwest and the West. So these are pasture and range conditions across the US. Of course, a lot of pasture and ranges in the West. And that top graph is showing the percent that is in good or excellent condition. 2021 is in that red line, and you can see it was for most of the year the lowest percent in good and excellent condition we'd ever seen. It's now kind of dancing back and forth with 2020, but we're still looking at less than 30% of our pasture and rangelands being in good or excellent condition, and you know, around 20% actually being in very poor condition. Just, you know, for another example is that spring wheat conditions are actually kind of alarming. You know, we're seeing maybe about 10% of our spring wheat area in good and excellent condition, with over 20% in very poor condition. You know, I've heard as a result that hay prices here in Nevada are varying between $200 and $400 a ton, which of course is high and also a significant problem for folks who are trying to raise cattle on that range, which is also not in great condition. So our bottom line here is that summer rains were a real benefit to parts of the Southwest. Unfortunately, they were also messy. There was some flooding associated with those rains without their fully resolving drought conditions. So drought is still with us, and we're still seeing drought impacts in terms of water resources and everything that goes with water resources, whether that's concerns about hydropower generation or recreation. I know in many of the larger reservoirs, fishing has been curtailed, boat ramps have closed, and we're seeing this across the Southwest. There are wildfire impacts. here in Reno, we were just downwind of the Caldor fire, and the city of Reno experienced several days with unhealthy and very unhealthy air quality conditions. Right, this is in addition to everyone directly impacted by wildfire. Of course, there are agricultural impacts as well, and those appear to be pretty widespread across the Western U.S. And so I am going to try to be timely and move this back to you, Joel.
Thanks. We're going to jump straight over to John. I'm going to make John the presenter now. So John, you should see something pop up on your screen to accept that baton, and then take it away as soon as you're ready.
Okay, sounds good. Okay, I hope everyone can hear me fine. Again, as Joel mentioned, my name is John Gottschalk, and I'm with the Climate Protection Center in Washington, D.C. And so I'm going to be presenting some of the latest outlooks, but also provide, a brief overview of the seasonal outlook process and some of the scientific information going into their preparation during the short talk. Just for folks who are not aware, our seasonal outlook process, we release it once a month. It's always on the third day of the month. That's the fourth bullet down. And the outlook is what's important to note that I want to focus on with this particular slide is that the outlooks are for the mean temperature over a 3-month period, expressed as one of 3 categories in probabilistic form, meaning either the below normal category or bottom third of the typical historical range of temperature, or also total accumulated precipitation is noted there as well. The middle category, or the middle third, or the upper or the high third of the historical range during that particular 3-month period. And so it's the maps that I'll be showing from the outlook perspective are probabilities for one of those 3 categories, and the one that's displayed is the most likely or favored category of the 3. This slide gives some example of that just for quick interpretation as I go through some of the other outlook images on the next following slides. What's shown here, the first thing that's important to note is that the maps that I'll show and the ones that we release every month, they show one variation of colors, but basically it shows the probability of the most favored category. But actually there are 3 probabilities for every location on this map, and this particular plot is one to try to illustrate that. For example, if you take a look at the image on the left of this slide, which is the green areas, which is signifying elevated odds above climatology for above normal 3-month total precipitation amounts. You can see as the arrow points down to the left that probability is the highest at 46%. But you can see there are non-trivial probabilities for the near normal category or the middle tercile category, and also 21% as an example for the below normal precipitation. And I won't go through this example, but a similar example is shown on the right for below normal precipitation, where you see the highest odds are that in the pie chart to the left of that main map, are 47% probability for below normal precipitation in that particular example. So going into some of the outlooks before going into the process, this is the October temperature and precipitation outlook released this morning for on the temperature on the left, precipitation on the right, and focusing on the western and southwestern region. As you can see on this particular map, we are favoring or leaning towards above normal temperatures for the month of October across the southwest. There are higher probabilities just to the east of your region, across parts of the plains and into the northern Ohio Valley and Great Lakes. And as far as precipitation goes to the right, continuing to expect to see below normal precipitation, which is kind of the trend that we're starting to see in some of the shorter range outlooks that I'm not going to show today. But we do expect below normal precipitation amounts for the month of October, as shown here, with the highest likelihood across parts of New Mexico and western Texas and southern Arizona, where the darker shade of beige is. Or as you extend this out into the 3-month period, or the seasonal outlook, which covers the October, November, December period. And again, this is for the seasonal or 3-month mean temperatures for that 3-month period, and 3-month probabilities for the total precipitation amounts, again, summed over those 3 months. The story is basically the same, expecting or favoring above normal temperatures for much of the Southwest. In fact, some of the highest probabilities anywhere in the particular forecast domain here are across parts of the Southwest. And also on the right, as you can see, again, a continuation of below normal precipitation expected. As we get into this particular seasonal outlook, we're starting to see, these are reflecting some of the influence that we expect to see from developing La Nina conditions, which typically produce drier than normal conditions along the southern tier of the U.S., typically from various points in California eastward across the Southwest and along the southern plains, and also across parts of the Southeast and extreme Gulf Coast. So this is what we're favoring moving forward with temperature and precipitation. And how this goes with the expectation for the drought outlook, which was released today as well. And Steph did a great job of communicating the wet conditions during the summer months. Things have dried out somewhat in the sense of precipitation amounts most recently, and we expect that to continue as I showed in the outlooks. But given the amount of rainfall or precipitation in general that has fallen across much of the Southwest, the forecast should determined to just leave it persistence for right now until we see how the late fall winter precipitation that begins to ramp up in some of those areas sets up. However, to the east, with respect to some of the most recent initial conditions that Steph also showed, with conditions have been drying out somewhat across parts of the plains and the high plains, meaning parts of Colorado, eastern Colorado, eastern New Mexico again, and also parts of Texas, Oklahoma, and Kansas. And we are favoring potential drought development in that yellow region there. The brown area is the expectation that drought is just going to persist generally in its current condition. And it's important to keep in mind that this is what we expect the state to be by the end of the calendar year, so the end of December. So this is a forecast that's really extending out for the next 3 months as well. Now, moving on to some of the conditions and process that we do in making these outlooks. And I'll go through some of this relatively quickly in layman's terms as best as possible. The first one there is that there's a number of large-scale factors that affect what we call the base state or the mean condition. And one of those is just persistent and recurring atmospheric circulation patterns that are going on at the initial time of the forecast, where there's a number of different forecast guidance products that can expect those to potentially continue. And these can be in the atmosphere, but much more likely they are related to what we call boundary conditions that have some memory in the climate system. And these types of quantities have some impact with some lag into the atmosphere, the coupled atmosphere ocean land system. And these can be such things as soil moisture, probably better to phrase this as surface wetness in areas of higher vegetation cover, snow cover and depth, as well as ocean surface temperatures, which can be local as well as remote. And I think everyone's very well familiar with one of the leading remote indicators of these boundary conditions across the equatorial Pacific, which is the El Nino Southern Oscillation, or ENSO, in the different phases. This is one of the primary drivers of interannual or seasonal forecasts that we somewhat understand and know, and have some understanding of the evolution, and have a relatively skillful prediction tools and models for its eventual evolution. There are other, however, circulation patterns that are recurring and persistent that are less predictable at these time scales, meaning what the season will be. They're more predictable for the next week or 2 or 3, perhaps. And these are some higher latitude types of climate forcing patterns, such as the Arctic Oscillation, which you may have heard of, the North Atlantic Oscillation, and the teleconnection, such as the Pacific North American pattern. And these things play a large role as well if they persist in the seasonal outlook, but they're less predictable. And then one of the other factors is just longer term trends, which are the observable changes over the more recent period, say 10 or 15 years, as compared to the climatological normal, which we just switched to, which is the 30-year base period from 1991 through 2020. And so some of the strongest signals we have at times is this long-term trend, especially in temperature. With that as background, all the previous factors I had mentioned just on the previous slide kind of serve as the background state in which to use the additional information that I'm going to describe briefly here and then show on a couple of the remaining slides, which is that we have a number of different forecast tools and guidance products that we make use of for both temperature and precipitation. And these take the form of more statistical type models where there's statistically significant or reliable relationships between various variables and U.S. or certain regional temperature and precipitation patterns. And these can be lagged over several months. They can be referring to sea level pressure over the Pacific, the upper level jet stream and its location, things of that nature, and relating that to eventual or in a predictive capacity to temperature and precipitation across the U.S. We also then have numerical guidance or dynamical model forecast output, which is very similar, of course, to some of the weather forecast model output that many of your weather forecasts on TV and other places are based on. But we also have these models that extend out into the short-range, short-term climate prediction realm, meaning out to several months. And so we have this output from a different model sources that we utilize as well. And we're able to perform a number of different methods to make these forecast tools as objective as possible based on historical skill of the various methods and to help produce a first starting point for the forecaster often. And one thing I will say is that these dynamical model forecasts, although they're certainly not perfect, they are playing an increasingly larger role as we move forward in these outlooks. And so I wanted to, since I mentioned ENSO with respect, I wanted to just give a quick update on this. I think most people are familiar. La Nina is a cooling of the ocean temperatures in the equatorial Pacific, and it does generally produce a change in the circulation across the Pacific and North America, as shown in the bottom left. And typically for your region, as I mentioned earlier, typically conditions are drier than normal during the winter months because of a weaker jet stream, typically shifted further to the north. And there's also more generally high pressure and blocking so that storminess can be directed further to the northwest, into the Pacific Northwest, for example. This is not always the case, but this is a typical pattern when you aggregate all the many events. And so the official forecast of released earlier this month, the blue bars indicate the probability for La Nina. So you can see that we're at pretty high probabilities for the development of La Nina and eventually impacts as we start the October, November to December season and beyond, and then they begin to tail off after that point. And these are about over two times the climatologic probability. So right now we're in a La Nina watch. We expect over the next couple of months to start to see the ocean temperatures in the Pacific cool. And if that happens, we will then begin to look for whether there's a response in the atmosphere. And if we do receive that or see that, observe that, we'll probably issue a La Nina advisory at that time. And then we will have to wait to see what impacts, if any, we receive from the La Nina during the winter months. So we still have a ways to go there. So the remaining two main slides are just some of the examples of the type of products that we have from the statistical point of view that we use. The forecasters view this information is produced every month in real time for the forecasters to utilize. And again, some of the examples are shown on the bottom left, which I won't go into details, but they extend across the bottom row. And the top row has the statistical combination of those on the bottom row and the upper left. And then we have the North American multi-model ensemble forecast as an example in the middle, which is purely a dynamical model forecast. And then we have on the right a combination of everything in the upper right to help the forecaster get a feel for absorbing and processing all this different type of information. This is not an actual forecast for now. This is an example that was taken several months ago. This particular next slide is just an example of showing some of the numerical model guidance that we use from the North American Multi-Model Ensemble, or NMME. And not going to go through all the different patterns here. The main point is to show the bottom two rows. We have a suite of different models that produce forecasts of both temperature and precipitation, both in ensemble mean format, summing up all the information of those bottom two rows into the upper left, which is an aggregate type forecast. The middle plot in the top row is the probabilities of those forecasts bias corrected. And then the upper right, calibration for historical skill and ensemble spread in the upper right. So as you go from the middle plot to the right plot, you lose some of the coverage because we're screening for areas in which the model guidance has historical skill. So we want to make sure some of the information that we're looking at, whether it's reliable or not for the forecaster to use. So this is an example from precipitation. We also have it for temperature and then other variables as well. And so to summarize, as I showed in the beginning, still expect or favor above normal temperatures and below normal precipitation as we go through the autumn into the winter. As we get into the late autumn and winter, it's mainly driven by potential impacts from La Nina across the Southwest. As I mentioned, we do expect the development of La Nina and potentially associated impacts. And it is one of the primary drivers of the outlook this year, among others. And the third bullet is that CPC makes use of many forecast tools, both statistical relationships, as well as I mentioned, dynamical model forecast output, in preparation each month to produce the monthly and seasonal outlooks, which do extend out to about 1 year. And we do make use of the sophisticated techniques. We're always trying to improve these and adapt or ingrain some of this newer information or newer types of techniques into our forecast process to produce an objective historical skill-based methods to help the forecasters absorb and process the large amount of information they have available to help them concentrate on other things and as far as communication to stakeholders and other partners about the outlook. So I will wrap up there. I appreciate everyone's attention, and I guess I will turn it back to Joel.
Yeah, thanks, John. Emily here. I'll take it from here. And we have enough time for just 2 questions. But if you do have questions for the presenters, please do enter them, and we will circle back with you after the webinar. So the first question is for John. Can you explain the equal chance outlook, and what does that mean when predicting temperature and precipitation?
Yeah, so the EC outlook, or equal chances, as you mentioned there, what that represents is that we did not have sufficiently reliable or clear signals in the majority of the forecast products or tools that we use to make the outlook, or they were conflicting. Or another example might be if there's low historical skill in that region from that forecast information. So basically, what that's saying is equal chances that the probability for either above, near, or below normal precipitation or temperature, as you're expressing, is the climatological probability of 33%. So basically, it's an educated we don't know, if you will, in the sense that based on the information that we have available and our confidence in it, we don't see a particular strong evidence to make an outlook or a shift away from the climatological probabilities of any of those categories.
Excellent, thank you. Thanks for that answer. And for Steph, you showed that this past summer was very wet in parts of Arizona and Utah and across the Colorado Plateau. Can you talk a bit more about how that high rainfall affected our short-term and long-term drought conditions?
Sure. So, I will say as well that this was pretty variable. These were summer thunderstorms, so in some places the precipitation was pretty patchy, but we saw in many places soil moisture recover quite a bit. The folks at the National Weather Service office in Elko have a soil moisture sensor, and it went from bone dry to pretty wet over the course of a few days. Now, in some ways that was great. It did come a little late in the season, but I'm sure that it helped out some vegetation. For some kinds of vegetation, it might have just been too late in the growing season. But we saw wetter soils, probably some vegetation recovery. On the other, and that was a real benefit in places. We also saw fuel moisture recovery. So for a few weeks there, fire became increasingly unlikely because stuff was just too soggy to burn. On the other hand, we did also see both flooding and some debris flows triggered by these heavy rains. I will say as well, in many cases, the rains were beneficial for temperature as well. Somehow I skipped over my temperature slide, but in June and July, we were seeing temperatures anywhere from 2 or 3 to 7 degrees above average. And when you had those rainstorms come in, the temperatures would typically cool off a little bit with some of the cloud cover. So that was quite nice. Actually, at one point, I was jealous of Las Vegas because it was cooler in Las Vegas than it was here in Reno, which is pretty unusual.
Excellent. Thanks, Steph. So thanks to our 2 experts, Steph McAfee, Nevada State climatologist, and John Gottschalk with NOAA's Climate Prediction Center for joining us and sharing their knowledge. Thanks also to Joel Lisenby for continuing to co-host these Southwest Drought briefings with me. Our next briefing will be on October 26th at 12:30 Mountain Time. We'll hear from Dave Dubois, New Mexico State climatologist, about conditions and an update on those, and Anna Weinberg of the Drought Learning Network Sharing Management Practices team. And that team works to share what people are doing in response to drought and how that builds resilience. This concludes our September Southwest Drought briefing. Thanks for joining us.